Okay, I just wanted to go over this just in case that would have been helpful. That would be helpful for anybody. So, okay, plot the points. All right, so this is definitely given to me in, this first one is definitely given to me in point slope form. I can see it looks the same as this point slope. So just a heads up, the question says if the equation of the line is provided in general form, convert to slope-intercept form before plotting. Okay, that's fine. So this is in point slope form, so we don't have to do anything. So basically the slope, I can tell from the equation, the slope is -1/4. What's my point? The point has to be -7 and -1. Because that's literally just what it has to be. If I were to, here, why don't I get just a little random piece of paper? So, because let's say m is this and my x1, y1 is -7, -1. So when I plug that into my little like template slash blueprint for point slope, it'd be like y minus -1, m, replace the m value, x minus -7, which is how it ends up being like y plus 1. So yeah, important to be able to pull out this information, because once we have that information, it's actually pretty chill at this point. So -7, -1. And then from there, I just want to use the slope to like basically get every other point that I can, which has integer coordinates, because it says this thing about plot all points on the graph where both coordinates are integers. So basically, that's just exactly what that's telling us to do, is just go from this point and use the slope to get your other stuff. So I go down 1 when I go across 4. Down 1 across 4. Down 1 across 4. Down 1 across 4. That's going to be all my possible points with the integer coordinates. So just grabbing my little ruler, so then I can just do my straight line. Okay, so yeah, that's that. So this one's also point slope. So slope I can see is 2, and my point has got to be +3, -2. +3, -2, okay. So 3, -2 would be 3, -2 here. And then I can use the slope of 2. That means I'm going up 2 every time I go across 1. So I just want to fill in all of those potential points. Well, all of those actual points, just to follow the instructions about plot all points on the graph where they have all integer coordinates. So like where both coordinates are integers. So I'll just draw my line, and that's good. Okay, so for this next part, so this is in general form. I guess it says to convert to slope-intercept form. So I guess I'll do that. I don't know, I guess I was just trying to make sure that people could convert, so just wanted to like include that in the assessment. So I basically want it to become y equals. So let's just get the 3y on its own for a sec. So 4x minus 24 equals 3y. 3y equals 4x. Then I would divide both sides by 3. 4 over 3x minus 8. Okay. Just gonna quickly check that that's the same thing. It's gonna be a little weird because I just have to check on my computer. 4x minus 3y minus 24 equals 0. And then okay, good. Yeah, they are the same line. So that's cool, because basically at that point, it's just regular y equals mx plus b. So, like, I can plot my little y-intercept, and then I have to go up 4 every time I go across 3. Across 3, up 4. Across 3, up 4. Across 3, up 4. I think that's all of the integer coordinates points I can do, because I can't go over 3 anymore. Okay, so that should be that. And, okay, then let's, finally this one. So 10x minus 7y minus 70 equals 0. So let's get y by itself, or at least head towards having y by itself. 7y, divide both sides by 7, y equals 10 over 7, x minus 10. So why don't I just double check that one too, because I just don't want to have anything. Oh shoot. Oh, I think the video's still working. I just kind of mixed something up, but hopefully everything's fine. So I just don't want to hit that again because it kind of disconnected. So 10x minus 7y minus 70 equals 0. And then the next one is y equals 10 over 7 x minus 10. Cool, it's the same line. So basically, I'm just like checking in Desmos that like when I've converted here that I actually did it properly, just because obviously it would suck for the video to not have it correct. So here my y-intercept is negative 10. And then basically I go up 10 every time I go across 7. So let's go across 7 and I go up 10. That's actually the only other integer coordinate point I can put in there, actually. So, I mean, I guess I'll just like, yeah, connect. Yeah, because I can't go over like 7 again. So that's pretty much it. So yeah, that's like the first page. Yeah, like, I mean, obviously like pretty chill if like you are comfortable doing the plotting, but obviously like very not chill if like you aren't 100% sure about it. So just, yeah, let me know if I can help with that. So let's go on to the second part. Okay, so this is like kind of a bit of an extension on what we've seen before, because we've definitely like done the part where it was like get the slope, get the y-intercept, get the x-intercept, get the slope-intercept. So this is all like stuff we've seen before. We haven't done, well, this is the first assessment where we do this part. So let's do this. So just remember it's going to be x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. So all of that just to keep in mind, because with slope, like, we're definitely going to use our slope formula, which is written on the front page, in case anybody forgets. So, or like, not in case you forget, but just so that you don't have to remember. 31 minus 13 over negative 6 minus 2. I'm just going to do all of this like at once. All the slopes at least. I don't know. Maybe that's, well, I guess I'll just do it one at a time. So 31 minus 13. Just going to use my calculator so that I'm not making any weird errors. 18 over negative 4. So slope equals negative 9 over 2. Okay. Okay, I'm gonna like honestly move my stuff down here because it's just, I should probably be using the space down here, to be honest. So, basically, b equals y minus mx. Remember, with the y and the x, we basically pick any point, any of the 2 points we have. So let's just pick this one. Yeah, let's just pick the first one for all of them. So that's gonna be 13 minus negative 9 over 2 times negative 2. 13 minus 9. 13 minus 9 is 4. B equals 4. So that gives me my equation. So my slope-intercept form equation should be negative 9 over 2x plus 4. And why don't I just double check? And that's where I'll go to the Wolfram Alpha, because that website is good for this. Because obviously everybody makes mistakes. It's just better to just check. Yeah, okay, good. So, okay, found that out. So we have this, and that's done. The y-int is going to be 0, 4, as we just figured out here. The x-int, just remember, to find an x-int, you always, like, substitute 0. So 0 equals, like, substitute y equals 0. So negative 9 over 2x plus 4. Then I want x by itself, so I'm going to minus 4. Negative 9 over 2x. Then I would, to get rid of the fraction, I can multiply by 2, so negative 8 equals negative 9x. So x is going to be 8 over 9. Let me just double check that, because I don't want any weird stuff. I don't want any weird errors in the video. X plus 4. So, yeah, it looks like that's, yeah, 8 over 9. It is that. So, So that means I want to write this down as the ordered pair, which would be 8 over 9, comma, 0. Honestly, like, I kind of want to, like, just do all of the, like, the stuff that we've done before, and then maybe go back and do this, because, I don't know, I just feel like I just want to get this part over with. Okay, so why don't I just double check? I'm just gonna be like double checking, so. Okay, good. So we know the slope. Then I can use my slope in my little, like, I'll just do it down here so that I don't run out of space. B equals y minus mx. And remember, I use, like, any of the points as my x and my y. So negative 36 minus 5 over 2 times negative 8. So that's going to be negative 36. That's going to be a negative 4. So minus... Well, I guess I can think about it as negative 40 over 2, which is negative 20. So that's negative 36 plus 20, which is negative 16. Oh, thank God. Yeah, it is that. So B is negative 16. So that gives me my y-intercept, which is 0, comma, negative 16. So that gives me my y equals mx plus b. So I have that. Then I can use that to figure out my x-intercept. So 0 equals 5 over 2x minus 16. 16, 5 over 2x, 32, 5x, x equals 32 over 5. Okay, let's just double check. Wonder if I can, like... Oh, whoopsie daisies, I just did something weird. Five over 2x minus 16. Yeah, I think that might actually be correct. 30, yeah, 32 over 5. Yeah, it's basically like, I just checked Desmos, it says 6.4. We can put that as a mixed number if it's better for us that way. 6, 2 over 5. Yeah, 6 and 2/5. That looks a bit nicer. So 6 and 2/5, comma 0, which is the same as, like, it's the same as like 32, comma 0. So, okay, we did that. Okay, I'm just getting this part all done, so, like, as in the first few parts. So, negative 17 plus 22 over 32 minus 40 equals 5 over negative 8. So it's negative 5 over 8. Let's check. Because I don't want, I've already said that 1,000 times. 40 comma negative 22. Okay, good. So that looks like the slope is correct. So then if we go here, I'm just going to go down to the bottom of the page so I don't run out of space, but b equals y minus mx. So we take the point y negative 22 minus 5 over 8 times 40. It's going to be like negative 22 minus, it's going to be a bit of a weird number. Negative 5 times 40 divided by negative 200 divided by 8. That's not going to be that nice of a number. Okay, so negative 22 minus 100 over 4, 50 over 2, which is basically like negative 22 plus 50 over 2. So negative 44 over 2 plus 50 over 2 to have a common denominator. 6 over 2. Oh, I guess it works out. Maybe 200 over 8 is divisible. Oh, I didn't realize 200. I didn't realize 200 over 8 was I might just, for clarity, just change how I wrote that, because I don't want you to think that you need a common denominator when you don't. Because since that makes me happy too, because I don't really necessarily want you to have to do the weird fraction operations. So minus 25, negative 22 plus 25, b equals 3. Okay, and that is correct based off of Wolfram. So the y-intercept is going to be 0, 3. The x-intercept, we have to set our, oh, well, okay, so that gives us our, knowing the slope and the y-intercept, we know this is this plus 3. And then the fact that, like, now we need to find the x-int, so we need to set y equal to 0. So negative 5 over 8x plus 3 minus 3, negative 5 over 8x times everything by 8. Negative 24 equals negative 5x. X equals 24 over 5, and that would be fully simplified unless we were going to change it to a mixed number of 4 and 4/5. So let's just check that. Y equals negative 5 over 8x plus 3. Oh, whoopsies, I'm doing something weird. 5 over 8x plus 3. Does it work? Yeah, it ends up being 4.8, which is this. Yeah. So that's good. So we have our x int, which is 4 and 4/5, comma 0, which you could also write it as 24 over 5, comma 0. The main thing is just not using weird decimals, please. Okay, almost there, at least on the kind of stuff we've done before. -4 plus 5 over -1 minus 5. 1 over -6. So it's -1 over 6. Just going to check. Yeah, so the slope is good. Oh, let me just block this off because this is, I don't want this to get in the way. This is a different question. So, I have my slope. So let's go all the way down here because b equals y minus mx. So, -5 minus -1 over 6 times 5. So it's going to be -5 minus 5 over, minus 5 over 6, which is going to be -5 plus 5 over 6. Okay, we actually do need a common denominator here. So my common denominator would need to be 6. I already have this. That's going to be -30. -30. Yeah. So then it becomes -25 over 6. So that's my b. Cool. That is actually correct. Oh, sorry, y-intercept. So it's 0, 0, so then that gives us our equation, which is -1 over 6x minus 25 over 6. Then let's just briefly solve for the x int over here. I guess we can 25 over 6 equals -1 over 6x times both sides by 6. 25 equals -1x. X equals -25. Let's just double check that. -1 over 6x minus 25 over 6. Yeah, it actually does look like the x into -25. Yeah, it is. Okay, so, that gets us like a lot of the way through the problem. So basically, let's do our conversion to general form. I might even like switch colors or something so that I don't have like, I don't know if that's a bad idea or not. I'm like, oh. Well, okay, fine. I'll just do it in the same color. I don't really have any other colors because I'm kind of scared to use pen and then mess it up. But if we start with y equals, so remember, the whole thing with general form is we want to get rid of the fractions. And we do that by multiplying both sides by the lowest common multiple of any denominators that we see. So when we multiply this by 2, it ends up getting rid of the fraction. And then now we're almost there because we just have to, here, let's just minus 2y minus 2y. That gives me 0 equals negative 9x minus 2y plus 8. But just remember, I need this to be positive, so 9x plus 2y minus 8. So you can swap the signs, which we also talked about as like multiplying both sides by -1. Because as long as you do the same thing to both sides with an equation, you're good. So I'm just trying to see, does Wolfram give me the general form? No, it doesn't. Well, I can check in Desmos. Okay, this might take a sec. 2x plus 4. 9x plus 2y minus 8 equals 0. Do we have the same lines? Yeah, we end up with the same lines. So this is good. We're done that. Why don't I just do my other little conversion to general form over here? Because it's just easier for me to think about all these things at once, all the same things at once. So y equals 5 over 2x minus 16. I'm actually going to multiply both sides by 2 here too, because I want to get rid of that fraction. If I move this over, 0 equals 5x minus 2y minus 32. And yeah, that should be that. Just check. Oh, I should really leave all these in here because I'm having to type a bunch of stuff again. 5 over 2x minus 16, and then we're seeing if that's the same as 0 equals 5x minus 2y. Yeah, those are the same lines. Okay, so over here we have y equals negative 5 over 8x plus 3. I'm going to times it by 8 to get rid of those fractions. 8y equals minus 5x plus 24. Minus 8y minus 8y. 0 equals negative 5x minus 8y plus 24. But I'm going to want to multiply by -1. Or just literally understand that you can just swap the signs. But at the end of the day, we end up with what we need. Y equals negative 5 over 8x plus 3. Let's see, is this the same as 5x plus 8y minus 24? Yeah, that's the same. So here, so this is where, you know what, actually there's none that have different, because with this one, we would just multiply the whole thing by 6 to get rid of the, both sides by 6 to get rid of the fractions. 6y negative 1x minus 25. Swap the signs. Oh, whoopsies, plus 25. Okay, that should be okay. Let's double check though. y equals negative 1 over 6 x minus 25 over 6. And then we'll see, is it the same as x plus 6y plus 25 equals 0? Yeah, those are the same lines too. Okay, so last thing would be to do point slope, which we are kind of good because we have our slope for all of these already. We already have our slope. So really it's just a matter of either plugging in the first point or the second point. First point or the second point. So you just have to pick. I'll just show both, but you're using the template y minus y1 equals m times x minus x1. Okay, so basically we are going to, okay, so y minus 13 equals negative 9 over 2 x plus 2, or y minus 31, negative 9 over 2 x plus 6. Either of these should be good. We can check that too, though. If we add y minus 13 equals negative 9 over 2, negative 9 over 2. X plus 2. Yeah, it's the same line. Y minus 31. It's the same line. So these, either of these would work. Point slope. Oh yeah, so same thing here. We have our points. So y plus 36 equals 5 over 2 x plus 8, or y plus 41 equals 5 over 2 x plus 10. So either of those. Yeah. Okay. I don't really feel the need to check those ones. It's like pretty okay. Take the slope x minus 40, or y plus 17, negative 5 over 8 x minus 32. Plus 22, so the minus positive 48. Yeah. Okay, and then with this one, same thing, take these points. X minus 5. Or y plus 4 equals negative 1 over 6 x plus 1. So yeah, that's like honestly a very intense page of ton of work, so much work, but also, I mean, a good way to show me what you can do. So yeah, pretty crazy, but there's a lot of skills going on there, which is really good. Okay, so last page. Okay, so line A passes through these points. So that's important, right? All of these things are important. So first of all, if line C is perpendicular to line A, why don't we just figure that out right now? So slope is y2 minus y1 over x2 minus x1. So that means negative 13 plus 7 over negative 10 plus 20. So negative 5 over 10, which is negative 1 over 2. So let me just double check that everything's fine. So, oh, I did something messed up. This is 6 actually, whoops. So then that changes things a little bit. It would be negative 3 over 5. Okay, so if line A has the slope negative 3 over 5, then I'm just checking my slope. I don't want it to be wrong and then do the rest of the question with the wrong thing. Yeah. So if this is my slope of line A, and I know that line C is perpendicular to line A, that means the slope of line C must be 5 over 3 because of negative reciprocal. So, okay, we know that piece of information. We also know we have the same x int as line B. So if line B has this equation, 4x plus 9y plus 16 equals 0, and I want to find the x int, so I would plug in y equals 0. Okay, so my x int is negative 4 comma 0. So determine the equation of line C. Well, here's the thing. I have a slope and a point, so I might as well use point slope. So y minus 0, 5 over 3, x plus 4, but I want that in general form, so I'm going to want to multiply by 3 to get rid of that fraction. So it's 3y equals 5, x plus 4, 3y equals 5x plus 20, 0 equals 5x minus 3y plus 20. Let's see if that's, oh, oopsies. Let's see if that's gonna work. So I'm just basically using Desmos to check my answers just because I don't have an answer key for a test that I created. So, okay, why don't we plug in line A first? So, actually, I don't really know that yet. So, 5x minus 3y plus 20 equals 0. So this, yeah, it looks like it has, the slope is definitely, when I go over 3, I go up 5. That's correct. When I go over 3, I go up 5. So honestly, the slope is good and it has the same, yeah, so this is correct. Okay, so if I'm here and I'm trying to plot line A, B, and C, okay, line A, all I had was the slope. So why don't we just find so line A, I know the slope is -3/5. Let's just find the B though, because I don't really know. Well, actually, because I already have these points, I don't really have to do that. To be honest, I don't actually have to do that, because I know that line A it already has -20, -7. So why don't I just put that on here? So -20, -7, -20, -7. And then -10, -13. I guess I mean, like, what I'm saying is, like, we can use the slope to figure out the y-intercept, but why don't we just solve for it anyways? B equals y minus mx. So we use either of our points. -7 minus times -20. -7 minus 60/5. It's going to be an integer. Oh, whoops. 12. -7 minus 12 is -19. So does that make sense? Because if we go over, the slope is -3/5. So that means I go down 3 when I go across 5. 1, 2, 3, 4, 5. Yes, it is going to make sense. Down 3 when I go across 5. Nice. So pretty much, if I'm trying to plot all points on the graph where both the coordinates are integers, then I just want to make sure I have this one in here. And when I go across 5, I go up 3. That's it for line A though. So this is going to be line A. That's line A. What's the deal with line B? Okay. Line B. Oh, right. Okay, so line B is a bit annoying. Well, I have it in general form. So let's do the thing where if we have... Oh, wait. Okay, fine. Line B is in general form. We have 4x plus 9y plus 16 equals 0. So we have, like, what is it? Like, okay, so to get the x int, so solve for x int and y int, plot those points. That's one way of dealing with this. So that's actually not gonna be helpful, is it? Oh, I see now that there's a bit of an issue, but okay, well, here's the thing. What I'm trying to talk about is, like, this is weird because it's gonna be like 9y plus 16 equals 0. So y is gonna be like -16/9, which isn't super helpful because it's not an integer, but let's find the x int. So 4x plus 9 comma 0 plus 16 0. 4x plus 16 equals 0. 4x minus 16, x equals -4. So, okay, at least, oh, I already knew that. Sorry, I forgot that, like, we already knew the x int here. But, okay, well, I know for line B, I definitely have an x int here. I guess the next best thing is going to be like, okay, well, my y int is, like, messed up. Because, like, I mean, it's, like, just annoying to work with something that's not an integer. But what about if we find the slope? So what's that gonna be like? Okay, oh, good. So I'm just gonna use some space over here. So if I have 4x plus 9y plus 16 equals 0, then 4x plus 16 equals 9y, y equals 4 over -9x plus 16 over 9. Oh, sorry, it's a minus. So first things first, let me just make sure I'm all good on that because I just don't want to continue the question and then be messed up. So 4x plus 9y plus 16 equals 0. Is that line the same as -4 over 9x minus 16 over 9? Yes, it is. So, okay, so this is line B's equation. So at least I know it has this point. And I also know that I have the slope of -4 over 9. So I can go from there. So when I gotta go down 4. 1, 2, 3, 4, and over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 4 over 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty sure. Oh, I guess I can just double checking. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I can't go 9 over anymore, so that's going to be my last integer coordinate on this side, but I can always go up 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yeah, and I wouldn't be able to go 9 over in that direction either, so those are all of my, like, integer coordinates or whatever. So I can draw this line in. That was line B, line B. Okay, and so line C, finally. Well, remember we had the, point slope for line C, so that seems like the most straightforward thing because we know it has the same x int as line B, but then the slope is 5 over 3. So line C has the point -4 comma 0 and slope 5 over 3. So that means I know I have this point. I'm going to go, every time I go over 3, I got to go up 5. 1, 2, 3, 4, 5. Every time I go over 3, I want to go up 5. 1, 2, 3, 4, 5. Over 3. 1, 2, 3, 4, 5. Over 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 3, 4, 5. 1, 2, 3. Okay. 3, 5, 3, 5, 3, 5, 3, 5. Yeah, so that looks fine. So, okay. Wow. Wow, 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 wow. Well, that was also a significant amount of work. Okay, so, well, at least there's my nice little finished drawing, I guess. Because, yeah, I have the same accent as, so yeah, line A. This is line B. This is line C. We can see these are perpendicular. One has a slope of -3/5. The other one has a slope of +5/3. So these are perpendicular, and it also has the same x-intercept as line B, which was the criteria, so we're good. Okay, so final question. So if line WX is perpendicular to YZ, that means slope of YZ will be here, will be the negative reciprocal so that's kind of like the crux of the question. So let's figure out the slope of YZ because we have, oh wait, sorry. Yeah, sorry, let's figure out the slope of WX because we know that. So -44 plus 4 over -3 minus 9 minus 40 over -12, 40 over 12, 20 over 6, 10 over 3. Let's just double check that. 10 over 3, 10 over 3, 10 over 3. Is that correct? What's that last thing? 10 over 3. Yep, it is. The slope is 10 over 3. So if the slope of, the slope of WX is 10 over 3, therefore the slope of YZ would be -3/10, because it'd be the negative reciprocal. And then basically, I have my slope formula, which is y2 minus y1 over x2 minus x1. And if I plug in all of my known values and my slope, then the only problem will be, well, it's not really a problem, but the only unknown will be that k. So -3/10 equals, what is it? 2 plus 10. 5 minus k, 5 minus k. So that takes me to 3/10, 12, 5 minus k. Then I'm going to cross multiply. cross multiply. Yeah, 45. K equals 45. There we go. So yeah, basically that's how that goes.